Hello and welcome back to another LeetCode problem. The problem of the day is LeetCode problem 611, valid triangle number. And let's just follow our systematic approach again because we're practicing communication and problem solving approach over trying to write clever code. So yeah, let's dive into it. So we're giving an integer array nums and we're supposed to return the number of triplets chosen from the array that can make triangles if we take them as side lengths of a triangle. So with triangles, you have three sides, and the sum of the shorter two sides needs to be larger than the length of the longest side. Otherwise, you have one long line and two short ones that can't touch, right? So, we can't just take any three numbers. We have to make sure that the two smaller ones are larger together than the longer side. Cool. And constraints for this problem are that we have at least one number, or maybe not even enough to form a single triangle, and that the values are between 0 and 1000 for the length of the sides. Now, length 0 means we can't really consider it to form a triangle, because if one of the sides is 0, essentially you just have two lines laying on top of each other. And for our complexity analysis, we're going to ignore the fact that the length of the nums array is bounded. Otherwise, everything would automatically be O of one time and O of one space. So that's no good if we want to do a proper analysis of the asymptotic runtime behavior or space requirement for the problem. Solution. Okay, so let's go through one example. Example 1. We have four numbers in here, 2, 2, 3, and 4. And if we use the idea of combining the two shortest one with a larger one, we see that we can pick 2 and 2 as the short sides and 3 as the long side. And the sum is 4, which is larger than 3. So this should be a valid combination. Yeah, and it is. So it's one valid combination. If we take but we can also take 2 and 2 and 4. So 2 and 2 being our short sides, 4 being the long side. And now we have 2 plus 2 is equal to 4. So this is not a valid triplet of numbers because they're not. The smaller sides are not larger together than the long one. They're exactly the same. So the triangle would just be flat. So it's not a valid one. So the next combination we can take is we can take the 2 and the 3 as the short sides and 4 as the long side, and 2 plus 3 is 5 is larger than 4. Great, that works. So that's our second combination. And we can also take the first two and the 3 as the short side, and then again 4 as a long side. That would be another valid combination. That's these two cases. So what is to note here is that we don't care if we have duplicate triplets, but we care that where they come from. So we can choose the same triplet coming from the same indices in the array multiple times, so only once. But here it works because we have the 2 twice in our array. Okay, example 2. So here we have an unordered list of numbers, and the output is supposed to be 4. So how can we build that? I automatically want to pick the two smallest first, right? So 2 and 3 is 5. They're larger than this one, that 4. That gives us two combinations, two valid triplets. And the next one is to pick 3 and 4. And 3 plus 4 is 7, which is larger than 4. So that's another valid combination. But we can't pick this 3, this 4 as the short side, and this as the long one, because we've already used this combination of indices to form a valid triplet. So reordering the indices of a valid triplet is not a new solution. So where does the fourth solution come from? Well, it's when we pick the 2 and the 4, which is 6, and that's larger than the long side, the 4. So that's how we get to 4. And what is nice is if you go through those examples by hand, is it instantly gives you a free suggestion how to implement this in code. So I found it much easier to start picking the two small sides and then just choosing the large one. So, and here it became difficult, but I still did that where I just picked the two smallest one first. So maybe we just need to sort the array, and then it's going to be quite easy for us to, just find two sides and check, how many numbers there are that are larger than the sum of those two. So that's the idea that I would follow now for the implementation. So we're going to sort the array first. And then what we could do is we could pick one number and then just check how many combinations of other two picks would work to give us triplets. So we would still have, well, the sorting would give us n log n time. Since we're only using, well, we only need one counter, that means we only need of one space, the constant space, so constant space. And we still need to iterate through the remainder of this array. So we have to lead with one index and then iterate over the other one. So I think it's going to be an O of n squared effort to do that. So let's just write down the runtime complexity that we found so far. So I think it's going to be n log n plus O of n squared time and O of one space. So the first thing that I'm going to do is I'm going to sort the numbers. And I'm going to have a result. That is the counter for how many valid triplets we find. And we're going to have, well, we need an index now. So we could pick the first number, or one of the small sides, or we could pick the largest size first and then try to figure out how many different small sides we have where the sum is larger than the large side of the triangle. So yeah, and because we sorted in ascending order, we have to iterate through this array in reverse order now. And a good thing to remember, at least in Python, is how to iterate backwards through an array. It's very simple, just the length of the array and -1, because that is the first index that will be used. And we know that in a range in Python, the end of the range is never inclusive, it's exclusive. So in order to go down with index to 0, we have to put -1. So it won't reach -1, but it will reach 0. And this is the step size, so we're stepping backwards. Our index is getting decremented at every step of or iteration of the loop. So that's the first thing. And let me see. Well, now we have to iterate through the rest of the array up to nums, right? So what we could do is we could say, well, we could have like a left and a right pointer. So it's kind of like a 2-pointer approach, I guess. Left and right. And we say left, we start at 0, and right, we start at index -1, because index is already taken for the long side. I think that should be about right, yes. And so what we do now is we have to have a loop. And we're going to do while the left is smaller or equal than the right. Yes, because it's smaller or equal to. I'm wondering if we do just smaller or if we just do equal. I'm not sure. So that's, yeah, we have to be careful with this. We have to be careful with that one. But maybe we'll do that in a second. So now we just compute what our values are, A, B, and C, right? We know that that our large side will be at index. We know that our first small side will be at left and the other small side will be at right. And now we do the check, right? If A plus B is larger than C, what do we do in this case? Well, we would try to reduce the sum. So we do right is equal to 1. Otherwise, we're going to increase left. And we actually need to increase all. So it's not like a binary search where we pick the middle. We actually have to iterate through all of them. So this while loop will be an O of n thing. And this is also an O of n iteration through the array. So that's how we get to O of n squared in our runtime analysis. So now the question of all questions is, well, how do we update our counter? So in the case that this condition is met, we probably want to add something to our result. But what is that? So let's have a look here. So we have the following case. We have a short side and another short side. We know that all the values between left and right can we say something about those values? So if we know, let's say, well, we can actually step through this example. So in the beginning, the index will point at the 4. The left will start at the 2 and right will start at the 3. So we know that these are valid combinations. So the 2 and the 3 together with the 4 is a valid triplet. But we also know that if we increase our left side, all of those combinations are going to be valid triplets as well, right? So when we increase the left side, before we increase it, we could actually say, okay, how many different values are between the left and the right side? So we need to count 2 and 3 and 4 is one combination, but also 2 and 3 and 4. This 2 is also a valid combination. So if this is 0 and this is 2, that means we have to increase the result by right minus left, and I think plus 1, but I'm not 100% sure about that. So yeah, I have a slight cold, which is why I find it hard to see, this with the off by 1 errors right away. But likewise, we could argue that, yeah, no, I think that's correct, because we don't increase our result in this case when we decrement the right. No, well, actually, we do have to do it right here. See, we have to do it here because this is only where we know that the length of the smaller sides is larger than the large one. So actually, we have to do it here. And let's just pick this example again. So we know that the 3 and the 2 are larger than our side 4. So if we keep 4 fixed, how many valid combinations do we have for another fixed 3? So if 3 and 4 are fixed, we have 2 valid combinations. And in our example, that would be right, which is 2, minus 0. So it's actually 2. So it's right minus left. So there's no plus or minus 1 here. Yeah, and you don't have to put brackets around this, but I like to do that just to make it a little bit clearer. So, okay. So in the next iteration, so we decrement right. So now we have the index is still pointing at 4. This right is pointing at this 2. And left is still at 0. So now we have 2 plus 2 is equal. So this doesn't work anymore. And now we have to increment the left side. But now left and right are pointing at the same thing, which means we have to get out of the loop. So maybe we don't need an equal here. I think that's pretty much it. So it worked with that example. In an interview, I might go through this example as well, but I'm just going to hit the test button to see where we are. And if we have a failure, I'm going to walk through this example. So let's see what's happening. So that works on both of our test cases. So before we do the final submission, let's just walk through this with some edge cases in mind. what if we have less than 3 elements in our nums array? So we will actually do this iteration, but because we set right to index -1, and we have the condition that left must be smaller than right, we will not execute the inner loop when we have less than 3 elements. No, yeah, when we have less than 3 elements, that's right. If we have 3 elements, then we will execute it exactly 1 time. So what if we have a side length of 0? Do we need to deal with that? Okay, if, So if we point, so the zeros are in the beginning of the sorted array, right? So we could have that A is 0, but because B is always going to be smaller than C, this condition will never be true if A is 0. So actually our solution takes care of the edge case of where we have a 0 length in one of the sides. So I don't think we need to take care of that as well. What if both are 0? Well, it's the same thing. What if all are 0? Well, then the inequality will still make this expression to be false, right? Yeah. So I think we should be safe there as well. Okay, I feel confident enough to try a submission now. Let's see how that works out for us. Oh yeah, so there you go. That's a nice one. Let's not to close this. Let's just look at some other examples. And here, for example, you can see somebody is looking at the brute force approach, where they just iterate over all of the triplets. By the way, this approach does not work. I tried it before, and it's because I think it's because there might be zeros in it, and also because it's not checking if nums1 and nums2 and 3 are actually the small sides. But you can try to implement it yourself to see that it doesn't work. I tried it and it didn't work. And yes, some elaborate explanations and some code that is horrible to read. Yes. And this looks very much like the solution that we have. It's just less descriptive. So that's why in an interview I like to, be a little bit more expressive with the numbers. Because it helps people to follow what I'm doing. Yeah, so anyways, that concludes this daily problem, and I hope you enjoyed it, and please try implementing it yourself and practice talking about your implementation while you do it. That's the only reason why I am recording these videos, just to force myself to talk. Thanks for watching.